A pleasant morning to one and all. Today, we are all gathered here on the remembrance of Environmental Day. Let us have a quick glimpse of this day. Every year, Environmental Day is celebrated on June 5th worldwide. It is commemorated to raise awareness about the environmental issues. One such deteriorating issue is climatic change. This year's theme is One and Only Earth. We should all play a role effectively while living in perfect harmony with the nature. With these words, I would like to call upon Dr. Jasmine A. Jacob to deliver the welcome address.
Good morning, everybody. I cordially invite everybody present here to this webinar organized by SNH Department, Agni College of Technology. As we continue our rapid global expansion, our mission is to manage solid waste which are being accumulated day by day around us. We are proud to have our scientist Dr. D.V. Nayak with us today to enlighten us with this recent highly skilled research accomplishment. It's my pleasure to invite our scientist Dr. D.V. Nayak, our managing trustee, chairperson, vice chairman, principal Dr. Srinivasan Alamandar, and our department HOD Dr. Arul Kulandevel, and other department HODs, all our faculty members, and all my dear students for this event. I welcome everybody once again. I am sure this event is going to be very useful for all my students. Thank you.
Thank you, ma'am. I now humbly request Dr. Arul Kulendevel, head of our department, to give the introduction about our guest.
A very good morning, my dear faculty members and students. Dr. Devidas B. Naik is a former head in Radiation and Photochemistry Division at Baba Atomic Research Center. He had joined in BASc through 27th batch of training school in the year of 1984. He had completed his MSc in Physical Chemistry from Karnataka University. During his degree program, he had secured first rank, and he had obtained his PhD program at University of Mumbai in 1991. His field of research in radiation chemistry and photochemistry. He has published more than 125 research papers in highly reputed journals, and he had delivered invited talks in number of conferences also. He was recognized PhD supervisor in University of Mumbai, HBNI, and Pune University. During 1994, he was worked in Horn Mainter Institute, and he was awarded Alexander von Hamilton Research Fellowship. And he was also he was recognized supervisor in the above mentioned university. In recent years, he has been taking active interest in developing methodologies for treatment of different types of solid waste. He has also written poems in English, Hindi, Marathi, and has printed 4 poetry books titled Emotions, Songs of the Earth, and Nature's Love, and Anand Gan, which contains poems in Konkani, Hindi, and Marathi. So actually, he is the well-known and highly knowledgeable person. We are blessed to invite you, sir. Actually, without your speech, this Environmental Day will not be completed. So once again, I welcome you all for this wonderful session, sir.
Thank you, sir. It's time for the most awaited speaker, Dr. Devidas P. Nayak, to share his research with us.
Hello.
Yes, Professor, you are audible.
I'm audible. So let me start. You have already come to the second slide. You can just display first slide. Hello.
Yes, Professor, you are audible. We are moving to the first slide.
Okay, okay. Hello. Hello, are you able to listen me? Hmm? Listen.
Yes, sir, we are able to hear.
Yeah, yeah.
You can
Hello,
start
good
now.
morning to you all. Can I start now? Oh, yeah, I shall start now. So, good morning to you all. First of all, I would like to thank Dr. Ms. Jasmine Jacob for inviting me to give this presentation. And as you can see, the title of my presentation is Methodologies for Management of Few Solid Waste. As you are all aware, in recent past, management of solid waste has become a big issue. So I have been doing some work in this connection 9-10 years, and some of the things which I have been doing, mostly I will be presenting. Slide, please. Next slide. Yeah. So as such, our mother is inherently very beautiful, which is giving us everything to live. Let's move it up. Yeah. And essentially, we should not make it the earth dirty by our activities. That is the main motto we should be having. So as long as we don't make it dirty, then we will not have the problem to take care of the waste which is being generated and lying everywhere on the earth. Next slide, please. Yeah. As many of you may be from rural background, so you must be aware, with less of consumerism, we see clean surroundings at rural places. So we don't have much of waste problem in villages and small towns, especially in big cities. Modern day lifestyles generate large quantities of solid waste, and that is becoming a problem, and which makes many of the cities quite dirty. Next slide, please. Yeah, you can go to the next slide. Yeah. So as I told you, almost for last 9-10 years, I have been doing these things. And this slide I had just incorporated. In year 2012, there were news reports on non-collection of solid waste in Bangalore and as well as Tirunanthapuram in a place called Vilappila Sala because of protests by the local people. So they wanted municipal authorities to take care of that, and that many places the waste was lying uncollected. So it was a big news item. Next slide, please. Next slide. Yeah. In Mumbai also, in a place called Thane, where there was some for just to highlight the issues, demanding a cleaner Mumra. Mumra is a suburb in Thane. NCP workers dump a truckload of waste in front of head office of Thane Municipal Corporation, just to highlight the issue how the waste lying at different places in Mumbai is creating problem. Can you go to the next slide, please? Move to the next slide, please.
Okay, sir. Okay, sir.
Hello.
Oh, okay. Oh, 1 minute.
Are you able to hear? Yeah. Hello.
Yes,
Hello.
sir.
Are you able to hear me? Are you
Yes, sir. Yes, sir. Yes, sir. I'm able to hear you.
Slide given. Yeah. So India is facing a big waste management challenge. Waste management. Yeah, almost 40 crores people are they are living in urban areas in almost 800 small cities and big cities. And in a year, almost 60 million tons of waste is generated, and out of that, about 42 million tons of waste is getting collected, and among that 42 million, only 12 million tons is getting properly treated, and rest of that is lying in the dumping grounds. So this is a big problem. Can you go to the next slide, please?
Yes, sir.
Yeah, yeah. And emissions from dumping grounds as well as incinerators, and also sometimes fires, they take place at dumping grounds, dumping places. They contribute to some extent to changes in climate also. Go to the next, please. Yeah. From a chemist's point of view, waste is essentially improper things and everything is matter. So there is nothing like waste. So we call something as waste when it is at improper place and which is of not of use to us. Otherwise, from a chemist's point of view, everything is matter. So in rural areas, there is no generation of waste, as I told you, to be treated in community basis. So you don't see any municipal truck or collection vehicle coming in rural villages for collecting the waste. It is mainly the problem in cities and metropolis. All the households are following appropriate practices to take care of the waste in villages. There is something to learn from these village practices. Whereas in compared to rural areas, in urban areas, the population densities are much higher, which and also they are economically better off, so their living standards are higher, and that leads to higher rate of consumption and also generation of materials which are of no use. So that is how we are getting more and more waste in the urban areas. Go to the next slide, please. Hello. Yeah. So uh, yeah. So, as you are aware, to bring down the waste, we have to follow this 3 R's practice. Essentially, we should reduce the consumption. Wherever it is possible, should reuse the thing. And some places where it can be recycled, definitely they should be recycled. That is how we can bring down the volume of the waste lying at the public places. And as I told you, there is nothing like waste, and large number of small pieces of materials put together can make a mountains of waste, and then it becomes difficult to take care of that. So the commonly found materials in waste are used plastic items, thermocol, paper, big as well as small pieces. Anyway, in India, big paper Radhiwalas come and collect old cloth materials, cotton threads, fruit peels, hair, coconut shells, glass, used flowers, apart from vegetable and other food waste. So each of these items, if they are kept separately at the point of generation, there are methodologies to take care of this. Only when we put together all these items together, then the further processing becomes difficult. Go to the next one, please. Go to the next slide, please.
Yes, sir. Yes, sir.
Yeah. Yeah. So in this presentation, I will mainly tell about how one can take care of waste thermocol. So large amount of thermocol is used in applications such as packaging for packaging of mostly the electronic goods like computer, television, fridge. Lot of thermocol is used. Insulation, crockery items such as cups, plates for making models, decorations, etc. In some of the states, for especially for decorations and student projects, they have stopped using thermocol. But many other applications such as especially packaging, lot of thermocol comes still, and thermocol, in some countries it is called as styrofoam or just expanded polystyrene. So it is the polystyrene molecule. You may be aware it is just a polymer consisting of styrene monomers, and it is quite light. So this polyester thermocol, it is quite light. Its density is around 0.02 to 0.03 gram per centimeter cube, and essentially it contains more than 97 to 98% air trapped in it. Go to the next one, please. Next slide, please. Yeah. As here I have shown you some pictures of thermocol items like this is on the right top. It is the fish box. In transporting fish also, a lot of thermocol is getting used. They very thick boxes they make, and it is quite good for fish transport. And in the below slides, I have shown the different types of shapes of the packaging material made out of thermocol. Next one, please. Yeah, as I told you, in many places in decorations also, lot of thermocol is used during uh, festivals and other places, and the thermocol is used in cutlery and other uses also. So all this after use, most of the time it is being thrown outside in a hazard way, and it becomes a very dirty scene outside. Next slide, please. Yeah, next one. You come to the previous. Next one, please. These are the decorations and models made of. There is one slide just so disposal and environmental issues. Thermocol is not often recycled many times because due to its light weight, as I told you, the density is around 0.02 to 0.03 gram per centimeter cube. Subsequently, it has large volume and it's low scrap value, especially in developing countries like India, who have lot many people collecting different types of scrap and they do some business out of it. But collecting thermocol means it is like voluminous waste, and the material content, the polystyrene content is very less. As I told you, density is around 0.02 to 0.303 gram per cc. Almost 1 kg of polystyrene will be present in 50,000 centimeter cube of thermocol. So if people have to get that polystyrene, that much waste has to be collected. Again, you have to transport it at some to some waste processing unit, and which will need some cost, and you need that much space also for uh, taking care of that waste storage and other processes. So because of that, it doesn't become an economically viable process, and because of that, not many people will be interested in collection, transportation, and bringing down its volume. Lack of consumer awareness also regarding suitable recycling facilities and collection methods. And used thermocol is found at garbage points, roadsides, and finds its way into ponds and sea. It also chokes stormwater drains. Many times nowadays, because of heavy rains, you find a lot of water collection at different places because the drainage is getting blocked by used thermocol. You can go to the next slide, please. Next one, please. Yeah. Yeah. So these are the frequent scenes which are seen by the roadside. Lot of thermocol lies here and there. So one needs to find some method to take care of and so that people will not throw all such unused thermocol after use at roadsides. So next one, please. Next slide, please. Yeah. So one of the method for thermocol, as I told you, it is polystyrene. Polystyrene is an organic polymer, right? So if any organic material is burned at very high temperature in presence of enough of oxygen, then the only chemical generated are water and carbon dioxide. As I told you, my thermocol is made up of carbon and hydrogen only, polystyrene. So if you burn it at sufficient high temperature and giving sufficient amount of oxygen, ultimately it will give water and carbon dioxide. But while burning, we will not be able to provide that much of oxygen. For example, if you just burn a styrene molecule, styrene has 8 carbon atoms and most 10, yeah, sorry, and 8 hydrogen atom. So to burn that, you will need for 8 carbon atoms, 8 molecules of oxygen, and again for 8 molecules of 8 atoms of hydrogen, you will need 4 molecules of oxygen to get water and carbon dioxide. But while burning, you will not be able to provide that much oxygen. So because of that, incomplete burning will give you hundreds of compounds such as the polycyclic aromatic hydrocarbons, carbon black, carbon monoxide, as well as styrene monomers, which are not good for health. So because of that, incineration is not a method to take care of polystyrene. Next slide, please. Yeah. So as that, and which are the methods available for thermocol disposal? One is the volume reduction by thermal compacting, that is by densifying. So most of these organic polymers, they have what are called as glass transition temperature. When it becomes soft and malleable, at that time the trapped air can escape. So when heating thermocol to temperatures, it has a temperature glass transition temperature of about 105 degrees. So if you heat thermocol in the oven at about 120, 130 degrees for some time, it will become soft and oxygen will come out, and then you will have volume reduction. So the second it can be broken into small pieces, granulation, and demolded into fresh thermocol items. And this is especially done where thermocol items are being made in thermocol industries in their making of the different types of giving shapes. They come out with different, and it is very fresh waste. So they can make it into small pieces and remolded into fresh thermocol items. And both these processes require transportation of large volumes of thermocol to processing units, as I told you. The next one, please. Uh, in Indian scenario, in few states, dealer of electronic goods such as televisions, refrigerators, they collect back thermocol used in packaging so that it can be reused for again packaging. And thermal compactors is used at few places like in Panjim and also in near Pune, there is a place called Anjangaon. They are making that thermocol, means they put it in a high temperature oven and thermocol is getting compacted. Next slide, please. Yeah, this is one styromelt. This is unit from UK. It is for thermal compacting of thermocol. It is like essentially it is a big oven in which one puts the thermocol and they heat it to certain temperature and then it will become compacted. Only the air will escape. So there is nothing like some organic compounds coming out. It is just about 120 degrees, which is it. And the thermocol, which is suppose if it is about 1000 cc, after compaction, it will become about 30-40 cc. Next one, please. There is one other technology. This is also thermal compacting, but they take it to slightly higher temperature. As I told you, thermocol, its glass transition temperature is around 105 degrees. Whereas polystyrene melting point is about 240 degrees. So in this green max machine, when you put the thermocol from the upper, it will go to a hot zone where essentially it is getting melted and it becomes more like a liquid. And when it comes out, again when at room temperature, it gets solidified. So you will get briquettes of polystyrene on melting. So here the volume reduction will be a little bit more. Recently, in Mumbai, in Thane, near Mumbai, there is a Thane Municipal Corporation. They have installed one machine, this Green Max machine, in their dumping place, where the one company, one Insupac company, in collaboration with Thane Municipal Corporation, they have installed this. And Thane Municipal Corporation, they collect thermocol and bring it to this facility, and they take care of it. and that condensed polystyrene, it is sold to some companies from which there are different photo frames or razors, different types of items are made from recycled polystyrene. Next one, please. So here one more, this one was thermocol crushing and mixing with beads to make fresh thermocol, as I told you, or use of waste thermocol in bituminous mixes to make roads. That is also essentially this polymer, it is mixed with hot bitumen and that is used for laying of the roads. This application, apart from thermocol, for plastic waste also, it was being tried at some place nearby Bangalore, and in Tamil Nadu also, in nearby Madurai, they used plastic along with bitumen or tar to make the roads. But only issue is such roads after some time, because of heavy traffic, if there are some issues of some polymeric particles coming into the air also. Next one, please. So essentially in this presentation, mostly I will explain how one can reduce the volume of used thermocol using acetone. So thermocol, when exposed to acetone, it just collapses and there is large reduction in volume, as thermocol, as I told you, essentially contains more than 97 to 98% air in it. And depending on type of thermocol, easily 97 to 98% volume reduction is achievable when optimum use of acetone is made. So thermocol collapses when it is exposed to acetone was known. And by the what I have done is a process has been developed or optimized to reduce this volume of thermocol. Next one, please. So acetone is taken in a wide mouth bottle with airtight cap. Yeah, I will just show you a video. Yeah, you are able to see me, no? So acetone is taken in a wide mouth bottle, like you call it as Bharane, no? So that it has a very tight cap so that no acetone escapes. That has to be this one. And after my presentation, I will show you small demonstration how it is being done. So thermocol pieces are inserted through the wide mouth of bottle, and initially thermocol collapses quite fast. In the time the acetone is there, as soon as you put thermocol in it, it just collapses. And as I told, yeah, depending on type of thermocol equivalent to 40 to 50 times volume of acetone is taken up in a few minutes. Suppose if you take about 100 cc of acetone in your bottle, so almost 5,000 to 6,000 centimeter of cube of thermocol will go in no time. As soon as you put it, just collapses. And then onwards, in that paste so formed, one can insert thermocol pieces in the bottle and keep it tightly closed, because you have to make optimum use of whatever acetone you have taken. Okay, next slide, please. Yeah. As you put more of thermocol pieces, they will go into it, and within 5-6 minutes again these pieces get collapsed. So and this process is continued till it becomes dough like material. For making rotis or chapatis, you make from wheat flour, no? So like that it becomes, and at this time one can give any shape required to it, no? Next slide, please. And while I will show you that dough like material also uh, in my presentation, and it sticks to wooden or cement surface. So after giving any desired shape, material can be kept on a cotton cloth, so that it soaks little bit of residual acetone in it, and you can keep on turning it so that one will not leave it at single place for a long time, so that it did not stick to that. Cotton cloth helps in soaking any residual acetone and fastens the hardening process. And more uniform material is obtained. So you can just squeeze it, give large surface area so that it can become hard at a shorter time. And initially I was giving a variety of shapes such as the Lord Ganesha, alphabets, numerals, and making different types of trays and other objects. I will just show you those of few objects also in my subsequent slide. Next one, please. Yeah, as I told you about that whatever material, when the dough-like material, it becomes quite hard after leaving it for about 5 hours. And essentially this helps also because as I told you, whatever little bit of acetone is there in that material, finally it will come in the air. So if as it takes lot of time for a little bit more time for drying, so you don't generate more acetone vapor also in the air in a short duration. So in 50 ml acetone, as I told you, about 5 to 6,000 centimeter cube of thermocol can be collapsed, giving a final volume of about 150 centimeter cube of dough-like material, which is mainly polystyrene. So the cost of acetone in retail slightly bigger chemical suppliers, almost 5 to 6 rupees on retail basis it is available. Next one, please. So in just the pictorially I have shown in this slide, in a small Barney-like bottle with airtight cap, you take about 50 ml of acetone and you have a big chunk of thermocol and you just make small pieces of thermocol and put it in that. Next one, please. Yeah. So just open it, make you need not make very small pieces. If it is a wide mouth bottle, that thermocol strip should just enter into that through that mouth. It can be of any length. Only the width should be such that it enters into the bottle. So as soon as you put it, it just collapses and you put it more and more. And finally, it will become like a dough, which is shown in the next slide. Next one, please. Yeah. So in this, all that chunk of the acetone thermocol has gone in it, and finally you get it like a dough. If it is in times, it is almost 50 times volume reduction, almost from 1000 cc of thermocol, it has come down to about 20 to 30 cc. That is 50 times, or in percentage, it is about 97 to 98% volume reduction. Go to the next one, please. Yeah. So these were the initial, I was doing different objects like small handmade Ganeshas. This is just our symbol of atomic orbitals, small trays, tumblers like that I was making. Can maybe Dr. Jasmine, she has seen such objects when she was in Baba Atomic Research Center. Next one, please. Yeah. When I was in service, I was staying in Anushakti Nagar. Anushakti Nagar is a BRC residential colony, and I put a display of different objects made from waste thermocol. You can make letters. I have made one nameplate of from that condensed thermocol material. You can just give a different types of shape, whatever you want. And this, by essentially, this is now polystyrene, and it is quite soft. So I actually, whenever you make some objects from industrial scale, whenever melted thermocol comes out, immediately it will become hard. Whereas here I have that scope to give different types of shape. So as it is quite malleable. Next one, please. Yeah. In about 2014 in Baba Atomic Research Center, we have one central complex auditorium. There I had given one presentation. Along with presentation, I had kept some objects made from thermocol, condensed thermocol, and these were displayed at that time. Subsequently, I am doing the many different items also. Next one, please. Yeah. So during last few years, at many places, right from our residential in BRC and many colleges, schools, and different uh, centers, I have been giving or presentation and also showing the demonstration of this methodology. Next one, please. Yeah, almost. Huh? Now, whenever I do such presentation, definitely from the audience, there will be a few questions. So before I get questions from audience, I have put some questions which are have been frequently asked. Well, the first and foremost question will be how safe is acetone? So all these chemicals, they have what are called as material safety data sheets. And acetone does, and especially people whenever we talk of chemicals, the first question will be whether it has some carcinogenic properties or whether it can cause cancer or something like that. So acetone does not have any reported carcinogenic property, and it is the major component in nail polish. Many girls, ladies, they use nail polish. So for removing, they use one liquid. That many times it is just marketed as acetone also, or some nail polish remover with some trade name. So the major solvent in this is uh, acetone only. So whenever they use two drops, finally it comes to the air only. And major solvent in metal industries and other things for cleaning the metal surfaces, it is acetone. And during metabolism of food also, some levels of acetone is generated in the body, and liver is capable of metabolizing it. And any chemicals, especially the solvents, they are what are called as the TLV values, that is threshold limit value, about 500 ppm. This is a very high concentration, and these threshold limit values are for people who are working in a chemical industry for about 8 hours. So, in this one point, I want to make it clear, as we take acetone in a closed bottle, as such, we don't allow acetone to escape into the air, and that the short-term exposure limit is about 750, and IDLH is around 2500 ppm. That is a very high concentration. Can it be a fire hazard? Normal precautions taken with any flammable liquid to avoid open fire source nearby. Earlier, in rural and places or villages, people were using kerosene stoves. So just if it is kerosene is used doesn't mean that it will catch fire. So proper precautions have to be taken. So whatever acetone is there, you should not bring any fire source nearby it. So that precaution is to be required. And other one is acetone vapors will fill the space wherever it is. As it is done in closed bottle, vapors do not escape. And also acetone vapors are twice heavier than air. Air on average molecular weight is about 29. It is 78% nitrogen, 21% oxygen. With that, it is about molecular weight is 29. And acetone molecular weight is 58. So acetone vapor, they will be twice heavier than air. So in a bottle, they will have less tendency to come up because the air is there. So they will be lying at in the bottle only. Acetone vapor pressure also is about 200 millimeters. So just because if you are keeping some acetone, it will not fill that room with acetone vapor that quickly. Next one, please. Yeah. As I told you, apart from this putting in thermocol in acetone, as the thermal compacting also in a big tray, thermocol is taken and it was kept in oven, air oven, about at about 125 to 130 degrees for about 15-20 minutes. You can on the right you can see how much volume reduction has taken place. Similarly, in a petri dish, almost 4-5 big pieces of thermocol, when they are kept in the oven, you get that much volume reduction. All these methods, what I'm telling, wherever this thermocol waste is coming out, if you do that volume reduction then and there, you will have no issue of transportation or storage requirement of storage space for that waste collected thermocol. So that is the main purpose of this thermal compaction or compaction using acetone. Next one, please. So along with this, I thought, as the title suggests, it is for proper recycling of, to come to the previous one. So these are the mineral water bottles, PET bottles, that they are made of that white material, bottle material is polyethylene terephthalate. And caps are made of high density polyethylene or PVC also sometimes, and you will have some labels also. And nowadays, this large number of PET water bottles are being used, and many places they are lying by roadsides. There are few people who collect those bottles and they sell it to some local vendor. So where they will take it for about 15 or 20 rupees per kg, and then they will transport in a big tempo or some place to a bigger dealer. who in turn will compact them and send it to some recycling unit. Actually, PET polyethylene terephthalate, you can get that polymer, you can recycle it into get it polyester fiber. And especially our Indian cricketers also, that's it they use. It is made from recycled polysters. PET bottles. But this process becomes actually whenever you use such bottles, if they are thrown outside, over the process they become dirty, get mixed with other wastes also. So I wanted to just propagate one small methodology. You can just remove the caps, then remove the label separately, and whatever PET bottle material is there, you can cut into flakes with a scissor. And this flakes, if you are making, they can be sold at a cost of around 40 to 45 rupees per kg. Whereas PET bottles somewhere, and in this process, you bring down the volume reduction also. So in our center, Baba Atomic Research Center, after many meetings and other things, large number of PET bottles were used. So if you just cut them just after the use, especially at a smaller place, it can give some livelihood for some people. And uh, the process has to be uh, what I mean, if it is done at a decentralized way, one can have a better way to take care of this. Next one, please. And taking, especially in big uh, uh, cities, we generate large amount of small pieces of papers, whether it is bus ticket, train ticket, or ATM receipt, or in supermarket cash receipts. So all these small items also, they make a uh, nuisance when they are thrown here and there. In our country, especially use paper items as newspaper, magazines, they are recycled to large extent. But in small things, small pieces of paper like bus, train tickets, ATM bills, receipts, all these create dirty surrounding. It is not a new thing. People earlier times also they were recycling paper by making use of to make paper mache and give different shapes. Instead of throwing small pieces of paper, one can collect them in a bag, preferably cutting in smaller pieces. Just if you put about 3,000 to 4,000 cc of these pieces can be soaked in water. After 2 days, same can be hand meshed into a pulp, and you can give different shapes to it, especially in smaller villages, small towns. Earlier, people were practicing it, but in big cities like Mumbai, Chennai, Bangalore, small children, they will not be aware of this also. Next, please. Next slide, please. Yeah. The pulp so obtained can be drained off of free water. Little amount of fevicol I was putting. Otherwise, one can put some methi flour, this one flour also, or some multani mitti, and you can make it thoroughly mixed. And this mixture can be put in a suitable container mold, having a few holes at the bottom with cotton cloth on it, and leave it in open for drying. Also, other shapes also can be given to this pulp. And after it dries, one can get quite sturdy items. Some of the items I have displayed in the next slide. Yeah, go to next slide. So these are the small few items which were made from that recycled paper. And if you are giving some color, especially acrylic color, if it is exposed to water also, it will not get wet immediately. Next one, please. Yeah. So in conclusions, so I would like to say small contribution from large number of people can make a big difference in our surroundings, whether it is thermocol, paper, plastic, or nowadays for polythene also, as I have not included in this, polythene, all this polyethylene, polypropylene, after they can be recycled into or different types of objects also, and again by catalytic cracking, they are converted into oil. So there are units in Nagpur, Pune, nearby Mumbai, where plastic is converted into oil. So just at about 400, 450 degrees in presence of some catalyst, it is heated and it gets converted into oil. That oil, it may not be like good quality petrol, diesel, but at least it can be used as furnace oil and other industries. And one more thing, recently, just to not to make nuisance of thin plastics here and there, people mm, take big bottles. This is almost a 2-liter bottle of different cold drinks which you get. And in this, you insert all those small thin plastic items, and just in one small bottle, you can store one more large number of those polythene thin wrappers which are coming with the different grains or pulses or some other carry bags which you are getting. They can be, instead of throwing here and there, they can be put in such bottles, and then they can go for some recycling. This is one method. Recently, it is being propagated. And go to the next slide. Yeah. So thank you very much for your patient listening. And as I told you, when I was physically coming for such presentation, I was keeping all my different types of objects for display, and also showing, making one small demonstration. So I will just make that small demonstration. As I told you, for thermocol recycling, we take such a wide mouth bottle, which you call it as a barni in our language. I don't know in Tamil how you call it. And I have put about 200 cc of acetone, and just hold it. Just open it. This is a thermocol strip. Huh? You are able to see it, no? Somebody can respond.
Yes, sir. Yes, we can see.
Yeah.
Little bit.
So,
Okay.
right.
It's clear. Yes.
It just collapses. You want more. So as I told you, it need not be made into small pieces. The purpose, it should just enter into the bottle. Huh? And lengthwise, it can be anything. Yeah. So as I told you, till the time free acetone is there, the process is quite fast. As soon as you put the thermocol in it, it just collapses. So if I take around, now I have taken about 200 cc of thermocol, mean almost 10, 12,000 centimeter cube of thermocol will go in it within 4 or 5 minutes. Then it will become like a thin paste, and then you keep it close and put some pieces and wait for 2, 3 minutes. They will be collapsed, and again put some more pieces, put it close. So if you continue like that, in 200 cc, almost 24 to 25,000 centimeter cube of thermocol you will be able to put it in it. Okay? Just to give a feel of that process, I thought I should show it. Okay. Okay. And finally, after you keep on putting more, and actually nearby our building also lots of thermocol gets collected as people are buying new television, fridge, etc. And finally, it becomes like a clay-like material like this. I have taken it out from that bottle, which I had. And this material, uh, You can give different shapes to it and leave it. And after some time, and these days I am mixing some other materials also into it, so that inherently, rather than coloring it after application, like this. And sometimes you can give large surface area, so that the process will be drying process will be faster. And again you can collapse it and make it so that drying will be faster. Recently I have been, earlier mostly I was making different types of this dog dolls and other things. Nowadays I am making so recently I am making such items like soap cases. When you can keep soap in the bathroom in this trays. So, and as this material is also, and make few holes in it, so that whatever residual water is there, it gets drained. And it is because it is quite hard. And to give a little bit better hardness, I mix little bit jute fibers. Jute fiber, jute in the Marathi it is called as sutli. So that thread, no, just like our rope, a thin rope. It is a, and that I cut it into small pieces of 1 to 10 millimeter length, and just exfoliate them and thoroughly mix them with this. So with that, it becomes quite hard also. And to give the color, I just mix little bit of kumkum. Kumkum means in English, whatever you apply. Sindoor you call it, no? That is, so that it gets 1 million, right, right. That color it takes. So these items, and it can give some people take it as a fashion, so that they can make such items, and it is a such a soap trace, maybe easily at 25 to 30 rupees. One can sell it also, because finally, if it has to become practically viable, there should be some economics into it, so that only some people will be interested in taking and taking interest and making some business out of it. This is regarding my thermocol this one. So this is what all I had to present in this how we can because the main message which I want to give is whatever kind of waste, we should not call it as waste. Some material, we don't bring any waste inside our house. After our use also, only when we are throwing it out, it is called as waste. Otherwise, it is some material of use to us. So that if we are able to keep it separately, and for each and everything, there are some techniques, methods available, and which can be recycled, and ultimately we can keep our earth very beautiful without making it dirty. Once again, thank you all for your kind attention. If you have few questions, I will be happy to answer. Are you able to hear me, Dr. Jasmine?
Yeah, it's very clear.
Yeah,
We can hear.
right, right. So now I come to the end of my this presentation, and if few questions regarding this presentation are there, I can answer. Otherwise, I wanted to tell you something about our Baba Atomic Research Center and some of the opportunities available there for your
Sir, you can tell about your Baba Atomic Research Center, sir, how to join and all. Then we can ask questions. No problem.
okay, that's friend. I was working in many of you must be aware. No? We have Baba Atomic Research Center at Mumbai. This is part of our Department of Atomic Energy. Not only Baba Atomic Research Center in Mumbai, we have Indira Gandhi Center for Atomic Research, IGCAR in near Kalpakkam. You must be aware, many of you know. That is also part of our Department of Atomic Energy. We have Rajaramana Center for Advanced Research Technology, RRCAT in Indore, and nuclear fuel complex at Hyderabad, and like that, many constituent units of Department of Atomic Energy are there, and uh, our department has two major activities. One is the nuclear power production. We have Madras Atomic Power Station. In our Karnataka, at Kaiga, we have a Kaiga Atomic Generating Station. In nearby Mumbai, in Tarapur, we have a Tarapur Atomic Power Station. In Gujarat, near Kakrapar. In Rajasthan, we have in Kota. In near, Uttar Pradesh, in Narora, we have different power stations. These power stations, their operations and building new reactors, it is being taken by Nuclear Power Corporation. Yeah, Nuclear Power Corporation. Whereas in Baba Atomic Research, we do a lot of reactor-related research as well as allied research in the field of chemistry, physics, biology. All that research is getting carried out in our research center. So, major of scientists and engineers who are working in BRC, they are joining through BRC training school. Some of you maybe might have heard of it, BRC training school. So in BRC training school, all engineers, whether it's mechanical, electrical, electronics, civil, computer, all those engineers, they are taken. And and MSc in chemistry, physics, biosciences, they can join, and they are given 1 year training in nuclear science and engineering. And after successful completion of training, they are posted as scientific officer C. That is a group A post of Government of India in different units of our department, not necessarily in BARC. There will be vacancies in Kalpakkam, Hyderabad, Indore, and there is one variable energy cyclotron center in Kolkata. All these places and few. So these are, and after joining, either you will be able to do a lot of research, or you may have to go to some research center where there is a lot of applied work also is getting carried out, and one will have further scope also. Our Department of Atomic Energy, apart from this research center, last 15 years, we have one Homi Baba National Institute, HBNI. It's a deemed university. So after joining, people go for MTech, PhD, and they get degrees from HBNI. Earlier, during my time, after I joined from, after completing my MSc in physical chemistry, I did my PhD while working at BARC. But for my PhD degree, I had a registration with Mumbai University. Those who were working in Kalpakkam, they were registering with Madras University, University of Madras. But nowadays, all our Department of Atomic Energy employees, while working, when they go for higher education like MTech, PhD, all their degree they get from Homi Baba National Institute. And you have a scope, especially in research-based division, you can pursue your interest in different fields, not necessarily in reactor and chemistry also, chemistry, physics. Apart from basic research, lot of applied research is also going on, because nowadays radiation technologies, they are being used in different whether it is in medical science for radiation therapy and radiopharmaceuticals, or in agriculture, different types of isotopes are used. In waste treatment also, we have one medical products. Nowadays, they are getting sterilized using radiation and using cobalt 60 gamma rays. You have waste, especially the sewage waste also is getting treated. So like that, for water purification also, radiation technologies are being used. So there are large number of applications, not that Baba Atomic Research Center means it is only research towards new reactors and this one. We have different allied applications in different fields which is being carried out. So when you are in before normally these advertisements come for BRC training school in the month of January, February sometime. And those who are in the final year of their degree also, they can apply. And sometimes in June, July, the interviews are held. And final interviews are based on the screening test. Initially, there will be written test, which is conducted at different centers all over India, almost 20-25 centers. And they will be having some cutoff marks decided for that, and few will be called for oral interview. And the new batch, now I think this is now 1981, 82 batch. So it is now 65th batch. With our BRC training school program started in the year 1957. So since then, every year, large number of engineers and scientists, they are joining through BRC training school. See, I thought I can, and this is a group A post. So if you are able to get through during your training program also, maybe about right now, maybe about 40 to 45,000 stipend is being given. And after completion, you will be getting about, one will be getting around 80 to 85,000 salary, and with other benefits also, because at every center we have accommodations after some provided for the employees, and schools and other facilities are also there. Many of you are nearby Kalpakam. You must be aware of that. You must have seen a large number of BRC, or some of you may be having your relatives also working in Kalpakam. Okay, thank you. Now you can ask me few questions, whether in my own presentation or regarding BRC also. Hello?
Thank you, sir. Thank you, sir. It's a very nice talk. Okay,
Yeah.
now
I kindly ask my fellow students to interact
Yeah,
with
yeah,
our chief guest.
right.
Professor, very good afternoon.
Yes.
This is Dr. Arul Kulandaivel from
Yeah.
SMS department. You have
Yes.
given a session in a very lively, Professor,
Right.
as in and very informative also. And but I
Thank you.
have one doubt, Professor. Actually, acetone. If you are using acetone, we will have some negative effects on our body, like headache and other issues. So
No, right. No, acetone, as I told you, in those frequently asked questions I answered. No, acetone, as I told you, it has no that way health issues. There are no reported of this one. And once when you are doing it, we will not be. Now I have two bottles of those bunny-like bottles just nearby me, so I don't get any smell of acetone also nearby me now. Okay, it is kept in a closed bottle, so the acetone vapor does not escape. And one thing I would, maybe I might not have told, it has not should not be in a very closed room. As far as possible, it should be a good ventilation, a ventilated room, so that whatever little bit acetone vapor also come, it gets dispersed in the air. As I told you, and I don't touch that acetone anytime. We just push that thermocol inside. Whereas when somebody applies acetone for just removing the nail polish also, finally you will be having some quantity of acetone touching your skin, right? So, but to that extent, it is being accepted. So, as I told you, that whatever acetone is there in that material, when you are keep it for drying, that drying process is little bit slow. Almost it takes, when I make such soap cages, it takes 5-6 hours for drying. That drying is so slow, it also means that whatever acetone escapes, it escapes at a very low rate, right? So that is also a beneficial aspect of that. Otherwise, once you take out some material out of that, and whatever residual acetone comes out in the air within a short duration, means you will be generating that much concentration of acetone vapor in the air. So that it takes reasonably long time for that object to get dry. It also is an advantage for that process. Okay.
Okay, Professor. Understood, Professor. Thank you. Thank you so much.
Excuse me, sir.
Yeah.
Sir, is there some way we can get permission for an industrial visit to BARC?
Actually, earlier times, many people they used to come. Of late, only BRC, where there are a lot of security restrictions. No, so but still, industrial visits are being, especially student visits, are getting arranged. So one has to write to our PRO. PRO is Public Relation Officer, BRC, with your details that you want to visit BRC for your industrial visit as part of your curriculum. Also, no, many universities during their MSc they have what is called a study tour. So you can write. They will just ask nowadays the details of the student about their number, or and once you are coming to at our entrance gate, they will take you to some few of the selected facilities. We have one research reactor called Dhruva. Hmm? There you will be taken inside soon from outside what is the being how the our reactors are operating. As I told you, there is one medical sterilization plant, or it is called as ISOMED. So where medical products are getting sterilized, and there is one food irradiation, the food technology division. So as I told, for the life extension of different fruits or vegetable like onion, potato, or such things, small quantity of or they are exposed to that level of radiation, that facilities they are explained. So one has to write from your principal or in charge professor to BRC authorities, and in that process, if you have somebody in service in some of the divisions of BRC also, you can get in contact with them so that it will facilitate your uh, that process. But only thing, if the students are coming, they are arranging their accommodation and other things, BRC guest house or hostel, that may not be possible many times, because so when somebody is coming to Mumbai for some industrial visit, so their stay, if they are able to arrange it outside, then it is better. Okay. So, but
Thank you,
as
sir.
such, the visits are possible. Many times when I was in service, students from Mangalore University, twice or thrice they came to BARC. So they have to write to either to some, suppose uh, some, we are in BARC, we have different groups. So I was in chemistry group. There is one physics group. Similarly, there are different groups related to engineering sciences, reactor group, electronics group. So you can write to those director of those concerned groups also. Writing to BRC director means it goes to the very high level. So then uh, again he has to mark it to some concerned division and other thing. So either you one should write to public relation officer, BRC, or any director of any particular group showing your interest. Tell the giving the list of students and faculty member or members who will be accompanying them. And nowadays with the email and uh, other telephone, it has become easier also to correspond and arrange those such visits. Okay,
Thank you, sir.
thank you.
Thank you.
Yeah.
Sir, is it the same procedure for visiting Kalpakkam also, sir?
Yeah, Kalpakkam also, they will be having some selected facilities where visitors will be taken. And always it helps if some of you, your faculty members or student, know someone working in where this one, Kalpakkam, it will be a little bit of a help. Otherwise also, our PRO, they will they put someone from their division section to facilitate the division visit to different facilities. No, because somebody will need some coordinator for that visit to take you around. So that type of thing is required.
Thank you, sir.
Yeah.
I kindly request Dr. Shanmugha Kanni ma'am to present the vote of thanks.
Take this opportunity to thank our scientist, Dr. Binoy, for accepting and invitation to speak every time with us, in spite of his decision. Thank you, sir.
Thank you.
In this session, waste disposal by various methods, 3R process, reduce, reuse, and recycle process, and dispose to the waste methods like landfill, incineration, and composting, especially local disposal without affecting the environment around us, like volume reduction, using acetone. Reuse of paper showed and making it here paste using alternative material made into useful object. I am sure our students are benefited from your calling speech. Thank you, sir. I also like this opportunity to thank our managing trustee, chairperson, vice chairman, our principal, Dr. Srinivasan Alavandar, SNH Dr. Arul Kulante, the head of other departments, faculty members, and all my dear students. Thank you, sir.
Thank you. It was my pleasure to give this presentation, and thank you again, all of you.
Okay, sir. Thank you very much for accepting our invitation and making this event successful. Many students are interested to visit, so definitely we'll make an arrangement.
Right.
And if you come to Bombay, definitely we'll meet you.
Right. Thank you.
Okay, thank you, sir. I once again thank
Right.
you very much. Oh, okay, with this we'll
Yeah.
finish our event for today. I thank each and everyone, those who are present here. See you all in the next event. Thank you.